All primates are united by having hands and feet, but the thing is that they use their hands and feet in different ways. And some primates are using their hands and feet to climb in the trees and access resources in the canopy. Other primates are moving on the ground, so they're terrestrial, but they're moving with all four limbs coming into contact with the ground. So one of the big differences that happened, one of the major pivotal events in the history of the Earth, was the transition from moving on four limbs to moving on only two. And the question is, does bipedalism necessarily and unequivocally equate you to a terrestrial lifestyle? And many researchers think that if you're going to be bipedal, you must be committed or wedded to moving solely on the ground. And other researchers have a different view, and they feel like bipedalism is a trait that allows you to access the ground when needed, and it doesn't necessarily exclude you from using the trees. So the assumption is once you get a foot like this, once you get the arch, which is a hallmark of humanity, having this arch, once you have the arch, then you are completely excluded from living in the trees, that you'd in effect be incompetent or evolutionarily incompetent for accessing trees. Yet at the same time, modern humans with a foot just like this regularly access trees, which is something that begs to be studied more thoroughly, and that's what we did. So the anatomy of the human ankle joint is thought to be closely associated with regular walking on the ground. Now if we look at the ankle joint of a chimpanzee, we can see it's relatively more delicate, it's relatively more slender. The calcaneus, for example, is not as large. And moreover, these smaller bones allow or accommodate a greater range of motion. For example, the chimpanzee can move its ankle in this direction towards the shin to a very high degree. So one of the things we observed during our research in Uganda is that humans are regularly climbing trees, and men in particular, and they're climbing trees to gather honey. And one thing we notice is that when they're climbing trees, they're climbing the tree vertically, and they're putting the plantar surface of their foot directly on the surface of the tree. And they're bending their ankle to an astonishing degree. So the ability to bend the ankle in this high degree appears not to be associated with the bones themselves, but it's possibly a soft tissue mechanism. And so that's what led us to look more carefully at the calf muscle, or what we call the gastrocnemius muscle. Now the length of the fibers in that muscle are what gives the muscle what we call an excursive ability. And what we found is that the populations that are regularly climbing trees to gather honey have longer muscle fibers, which is associated with a greater range of motion at the ankle joint. So what we have is a difference between two populations of people, one that regularly climbs trees and one that doesn't. And so we think it's highly plastic, that a lifetime of climbing trees that starts when you're a child has facilitated longer and longer muscle fibers, which is advantageous for climbing trees regularly. And so something like Lucy, a famous hominin from about 3.6 million years ago, it's quite likely, even though it had a foot that's very human-like in its overall anatomy, it could have had soft tissues, things that don't preserve in the fossil record, that facilitated effective tree climbing. And we think the mechanisms that are allowing people to climb trees effectively and regularly are something that they acquire through their lifetime. So one example that we think is pretty interesting is that women who wear high-heeled shoes, for example, it's quite the opposite effect. A woman who's wearing a high-heeled shoe is constantly contracting their calf muscle. And what happens over the lifetime of that woman is her muscle fibers actually get shorter and shorter, and her ankle joint becomes less and less excursive or more rigid. So what we're basically arguing is that the opposite pattern can also happen, where people who are regularly climbing trees and stretching that muscle fiber can over time acquire longer and longer muscle fibers.